Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 26, 2025, about 2 days ago. The striking idea is a real-time, interactive, digital human system that fuses an autoregressive large language model with a lightweight diffusion renderer and a deep compression autoencoder, delivering low-latency control from audio, pose, and text. The paper is titled MIDAS, Multimodal Interactive Digital Human Synthesis via Real-Time Autoregressive Video Generation. And as we will see later, the results are really impressive. The system streams frames with high temporal stability, multilingual lip sync, and fine-grained controllability for duplex conversation and beyond. Alright, the intro just set up the real-time goal and the multimodal control. Figure 2 shows how the deep compression autoencoder is trained in 3 stages, so the model stays both compact and temporally coherent. Phase 1 learns high spatial compression, which reduces frames by 64 times while keeping quality. Phases 2 and 3 add causal temporal modules, and then fine-tune the full model over an 8-frame window, so decoding remains stable and flicker-free during streaming. So, Figure 1 laid out the dataset pipeline that feeds the real-time system. The figure shows 3 stages connected in sequence, which matters because the autoregressive model depends on clean, well-labeled speech video. The pre-processing block collects sources, segments by transitions and speech shifts, filters by person count, and applies quality checks. The annotation and construction block adds automatic speech recognition, captions, emotion labels, and text-to-speech to create single, two-speaker, and synthetic conversations. The post-processing block performs manual evaluation, duplicate pruning, security validation, and data shuffling. Okay, the dataset pipeline set the stage for training. Figure 3 shows the streaming architecture that organizes multimodal tokens and frame tokens into chunks for real-time generation. Condition tokens for audio, pose, and text appear first, then the autoregressive model predicts the next frame's latent tokens, which guide a lightweight diffusion head so high-quality images decode quickly. Gaussian noise corruption on frame tokens reduces exposure bias, and dash chunk boundaries allow resets with updated inputs. While the architecture overview just showed chunked streaming with token ordering, Figure 4 illustrates the causal attention mask that enforces who can attend to whom across chunks, so frame generation stays coherent and real-time. Condition tokens remain visible to all frames within a chunk, while each frame attends to conditions, past frames, and its own intra-frame tokens. The block diagonal structure preserves temporal causality across chunks, which stabilizes one-step prediction and keeps latency low. Wrapping up, 2 takeaways stand out. The system unifies an autoregressive language backbone with a tiny diffusion head and a deep compression autoencoder, so generation streams with low latency, and the multimodal projector gives fine control from audio, pose, and text. The broader implication is real-time, controllable digital humans at scale. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.